Hello, everyone. I am Ronnie Cox. I'm going to be your moderator, and Mary Aycock is going to be our co-moderator for the next two sessions. We're going to get started. I have John Kunze. I know I said that wrong. Kunze in for this next session. He is from Drexel University, is a former Unix hacker who led publications of the first metadata standard, Dublin Core, unblocked approval of the first URL standard by writing RFC 1736, and created Baggett and the ARK identifier schema. John, the floor is yours.
Great. Thank you, Ronnie. Again, my name is John Kunze, and this course was co-developed with Donnie Winston. I'm a computer scientist who has been working with data centers, libraries, museums, and archives for the past 20 years. In Berkeley, California, I wrote software tools that come pre-installed on all your Mac and Linux systems. Then I moved into information systems and preservation standards, where I became the main editor or author of the first three metadata standards, which were Dublin Core. But before that, I wrote the formal requirements that moved that first URL standard over the finish line. Both those topics are important for today's topic. The trick to getting the URL or web links standard approved was to allow or to make it okay for URLs to be breakable, leaving persistent URLs for a future standard. So in a way, broken URLs are my fault, and it's my punishment that many years later, I'm still working to fix them. Now, in case you're wondering what a persistent identifier is, it serves the same purpose as a permalink. It's meant to persist, but there are no guarantees. So we're talking about URI or URL identifiers that were aspirationally persistent when created. Why should we care about ARKs? The average lifetime of a URL was once said to be 100 days. At the end of its life, a URL link breaks, usually giving you the dreaded 404 not found error that most of us have seen. While that can be irritating, it's a minor disaster for memory organizations. So ARKs can serve as robust links for any kind of thing in any discipline. The ARK scheme is one of 5 so-called persistent identifier or PID schemes. There's been a great deal of nonsense written about PIDs. Some of it is described in a Twitter thread called 10 Persistent Myths About Persistent Identifiers, which is available at the link using this example ARK or the QR code next to it. PIDs are permalinks containing hints that make them look different from the average URL link. Every URL is potentially persistent, but strangely, some people think it becomes persistent when it acquires some superficial syntax differences, such as the ARK colon in this example ARK, or when you see the domain name DOI.org at the start of a URL. The nonsense was in full bloom in the late 1990s, but it polluted the debate about the 4 proposed PID schemes. That is why the Archival Resource Key, or ARK identifier scheme, was introduced in 2001. So here's what an ARK looks like. At first sight, it's a URL that carries this internal label. To the right, the 5-digit Name Assigning Authority Number, or NAN, identifies the organization that created the ARK. Further right, after that number, is the local name of the thing that the ARK is assigned to. To the left, the host name makes the ARK actionable, or something you can click on. It's also known as the resolver. ARKs are unusual among PIDs in allowing organizations to run their own resolvers. The part starting with the ARK colon is the core globally unique identity. It does not depend on the host being available or on the future existence of the World Wide Web. In the previous example, you saw n2t.net, which is a global name-to-thing resolver. This is the main ARK resolver. So why doesn't it contain the letters ARK? Well, one goal of ARKs was to break out of the silos and walled gardens surrounding many identifier systems. So what got built was the name-to-thing resolver, or N2T. The domain name n2t.net is short, which is helpful in citation strings. Another big benefit of N2T is that it resolves over 900 compact identifier types. So if you forget where the resolver is for ISBN or protein databank or PIDs, or for ORCID, ROR, Handle, DOI, or ARK identifiers, just remember n2t.net. Not only does it track them for you, but it reduces the reliance on individual host names. And its compact identifier support saves precious visual real estate in citations. ARK organizations include a wide variety of memory institutions, nonprofits, for-profits, data centers, and government agencies. A few are listed on this slide. At the lower right is another example ARK identifier, which you can recognize by the signature ARK : inside it. This one points into the collection of the Louvre Museum. What are ARKs used for? Here are some examples. The biggest ARK user is the Family Search Genealogical Research Organization. Next is the archive of source files for journal content published in the global north. The Internet Archive has been assigning ARKs to scanned books and texts since 2008. The French National Library was an early adopter and has a wonderful image depicting the biblical ark. ARKs are also important for people, especially historical figures. For example, 19th century mathematicians Ada Lovelace and James Maxwell do not have ORCIDs, but they do have ARKs. If you're wondering, ORCIDs are open researcher and contributor IDs, so these ARKs are like ORCIDs for dead people. Finally, there are several projects assigning ARKs to vocabulary terms. Here's an example ARK from the British Library, whose NAN is 81055. Again, those 5 digits represent the NAN, or Name Assigning Authority number. If you're familiar with DOI prefixes, NANs are very similar. 67375, that's the NAN reserved for the French National Institute for Scientific and Technical Information. On the right is one of its 22 million records. Inside the red rectangle, you can see the ARK they assigned along with its NAN. Note how this ARK URL begins with their own resolver, not with N2T. It ends with an opaque string that tells us nothing about what it's assigned to, but we can tell from the metadata in the record that it's assigned to a conceptual thing. This example shows the NAN reserved for the Leventhal Map and Education Center, which partners with allmaps.org in the Netherlands. Inside the red rectangle is the ARK they assigned, along with its NAN. This shows the compact form of an ARK because it has no resolver in front of it, just the globally unique identity. Finally, this is a look at an ARK at the Internet Archive, whose reserved NAN is 13960. On the left is a major library standard that was digitized and deposited in their text archive, and on the right is its metadata record. Inside the red rectangle, you can see the ARK they assigned, its 5-digit NAN as well. Again, this shows a compact form ARK, so there's no resolver in front of it. Compared to the identifier field above it, the ARK is opaque, which helps it to age and travel well for external citations. People find opaque identifiers to be, well, opaque, but fortunately, you can see a bunch of metadata above that. That metadata includes 2 URN identifiers. Having multiple identifiers may not be ideal, but it's common, and it's often good practice to preserve all the identifiers that come in with an object. As durable, non-paywalled web addresses for any kind of object, ARKs protect whatever we invest in creating linked data. Each ARK contains a globally unique identity independent of the domain that is currently serving it. Unlike domain name centralized persistent identifiers, ARKs flexibly support the four main rules of linked data. For example, ARKs are expressible as compact URIs or as full HTTP URIs. So even in the case of a non-resolving ARK, recipients can still learn its origin by reading the name assigning authority at the beginning. Every URL is potentially persistent, whether or not it looks like a PID. Nor does a URL become persistent when you put a label like permalink next to it, or when the identifier starts to look like a PID, such as when ARK: or DOI.org is added to the identifier string. Identifier syntax is not magic. It is never more than a suggestion that this link may be more stable than the vast majority of URLs that are produced with no thought for preservation. Every PID is aspirational, based on the hopes of its creator, and there are no guarantees. As a result, PIDs break often by the hundreds of thousands, which is normal. Committed preservation providers will repair those links, those that can be repaired. Keeping PIDs persistent often involves the fundamental technique of indirection, stable identifiers that redirect to other identifiers. So this may be a reminder for many of you of this core PID technique of indirect identifiers, which uses the web concept of the HTTP redirect. So first, here's normal direct access. A user clicks on a URL in a web browser, which sends it to the web server appearing at the beginning of that URL, and a page is returned. With indirect access, the first server contacted says it doesn't know where the thing is, but it returns a message saying that this other named server should have more information. Behind the scenes, instantaneously and unknown to the user, the browser restarts the process by contacting the second server. It could be a third server, fourth, fifth, etc. This is web redirection, and it's like forwarding snail mail to a new address. Many of our ordinary web accesses involve long chains of multiple redirects, all taking place quickly and without the user being aware. So all PIDs are very similar in structure. They follow one pattern and have one basic trick, namely the simple web redirection that's been built into every web client and server for 30 years. Near the bottom, you see what ARKs look like, and above it, all the other PID schemes have very similar form. They start with a resolver, then a name assigning authority, and finally, a local name. For example, ORCID and ROAR are newer PID schemes using the same pattern and trick. Of course, identifying people and organizations is something that ARKs have been doing for 20 years. No PID scheme helps with any of the major causes of broken links, so you may ask why use PIDs at all, especially if there's a fee. One reason to use them is so that the recipient of your PID knows that it has a higher chance of resolving than the average URL. Extra services can coexist with resolvers, for example, to check for and report broken links. But no matter what you pay for your identifiers, it is still your responsibility to repair and maintain them. Like any permalink, a PID signals the presence of an aspirational link, but one that can be recognized in the wild when it is separated from any explicit label. Every web server since 1992 can redirect URLs to keep them stable, but only if the original server that the URL is based on still exists. If you think your server's domain name might not persist, you might be able to use a server that itself is aspirationally persistent, so that links can continue to be redirected. That's the second thing PID schemes offer, namely an aspirationally persistent server that might exist longer than your own. Examples are web servers at DOI.org or N2T.net or handle.net. If the original server no longer exists, you might still be able to update redirects on that aspirationally persistent server. Of course, any long-standing library or archive or any consortium or professional society could set up their own web server very cheaply. In fact, they do it all the time. and they would just agree to use it for their own PIDs. Either way, this only works if, and it's a big if the content still exists, if someone has the legal right to make it available, and if they are hosting it online. At the end of the day, redirects are an important but small part of keeping links persistent. To review, here's the grumpy old person view of PIDs. Looking at this table, the big block of no answers in the first 4 rows tells us that no PID scheme helps you with all of the major and most of the minor causes of broken links. So why even bother? Well, some of them are free, so there will be more money to spend on the real work of preservation. If you buy into the idea that PIDs actually provide value, here are some details on things they might do for you. By an amazing coincidence, this table is quite flattering to ARKs. The bottom line is always about cost. No organization pays for the right to create ARKs, pearls, or URNs in unlimited numbers. In the real world, or maybe it's just the academic world, PIDs that publishers use play a key role. When tenure and promotion hang in the balance, DOIs are the publisher's solution, and they are seen as a kind of badge of academic legitimacy. Pearls are free and are common in the semantic web. URNs are useful if you're a national library in a nation that subsidizes URNs. They have the unique advantage of having an internet standard behind them, even if it is frequently abused by creators of bogus URNs. Handles are popular in certain European projects and have a nicely underwritten resolver infrastructure, also used by the DOI system, so they can be good if you can afford them. If you only have a couple dozen things to identify in a year, by all means consider going to zenodo.org and assigning their subsidized DOIs. ARKs are similar to DOIs. Both are PIDs for content and metadata, and ARKs are found in many of the places where you find DOIs. In contrast, ARKs come with no fees, no limits on how many you can create, and no metadata requirements. From the beginning, ARKs have been decentralized and can identify any kind of thing, digital, physical, or abstract. Finally, there is no conflict using both ARKs and DOIs together, which is common in museums and libraries. Some people assign ARKs to everything, and for a subset of things that later need DOIs, they can derive them from the existing ARK string. This next use case is for the Smithsonian, whose NAN is 65665. You can see that number at the beginning of each ARK. You can also see the wide range of their object types, biological specimens, paintings, photos, and sculpture. Note the long opaque names they've assigned, which were generated using the UUID software that's pre-installed on nearly every platform. These unique names are long, unfortunately, but they're very easy to generate. Here are some more details of ARK syntax, including subparts and variants. Right now, we will focus on the NAN, or name assigning authority number. The NAN is a 5-digit number. As such, it is opaque, which is good for longevity. But what if you want to know what's behind the opacity? Well, in a browser's address bar, you can try truncating an ARK so that it stops after its NAN, as shown in the yellow highlighting. This is a stub ARK. If you hit enter after this incomplete ARK, it lets you inspect the 67375 NAN, which is from our an earlier case study. I encourage you to take a moment to go ahead and try this. You can also try it with other NANs, or you can try backing off further to a shorter stub, ending with just the ARK colon, which tells you about the ARK scheme. I mentioned that N2T can serve 100 or hundreds of other schemes. For example, try entering the protein databank identifier shown in the last line. You can also look at truncate that to the PDB acronym to learn about that scheme itself. Here's what part of a record looks like when you ask N2T to tell you what the 46171 NAN is. The record is, what you get back is more complicated, so this is an excerpt of those fields. You get the record for the National Autonomous University of Mexico, as well as when it was registered in 2017. Very importantly, it tells you where the N2T resolver should redirect incoming ARKs so that they get sent to the correct local resolver. All the NAN results that you can see by playing with stub ARKs in the address bar of your browser, they're all pulled from the main NAN registry. This is just a plain text file that you can look at directly in your browser. You can use the QR code if you're interested. Here's another example record for the National Library of France. Just a quick note, the registry file format is in the midst of being changed to a more broadly machine readable format in JSON. So it sacrifices a little bit of the human readability for still human readable, but it's more machine readable. The file that's currently linked to starts with a big lots of textual description, and you have to scroll to see the records in chronological order. To look for organization, you can use the browser find in page function. So the NAN has two main purposes. It's a lookup key for the resolution reference point, and by defining the root of a global namespace, it isolates an organization's autonomy and responsibility for assigning its ARKs. That way, without interfering with anyone else's assignment, an organization can determine its own policies regarding identifier form, uniqueness, and even reuse. Basically, just as for URLs under its domain name, an organization can freely assign ARKs in any way that it wants. Here's a link to the form you can use to request a NAN for your organization. If you want to practice using it, go ahead, just indicate in the final comments that you're filling it out as a training exercise. So I encourage you all to just inspect that, just get a sense of how it's done. Within 48 hours is the target response time to fulfill requests. So I'm not sure if you've heard about opaque identifiers and its pros and cons, but a great deal has been written about opaque identifiers. They age and they travel well, but it's not the complete story. Because they look like random combinations of digits and characters, they have no apparent meaning to any culture in any time period. Of course, there will be exceptions, but this is good because therefore they cannot mislead or give offense, or rather they're less likely to do that. But that virtue can be a flaw when people want a thing's identifier to hint at what the thing is. One approach to soften this inconvenience is to make the ID shorter and therefore a bit more citation friendly. Of course, the downside is that shorter IDs are harder to keep unique. One emerging trend is to use an opaque base identifier with lucid or non-opaque extensions. That can be okay because extensions are more transient than the base thing itself. For example, image thumbnails are regularly upgraded to be higher resolution. This happens every few years to keep up with evolving demand and advances in storage capacity, network, and rendering speeds. But the commitment to the overall thing is very firm, but the commitment to the bit stream delivered under the thumbnail may be less durable. Back to details of ARK syntax. We talked about the nan that comes right after the ARK label. Moving further right, the special characters slash and dot or period have special reserved meanings in ARK suffixes. So that makes those characters effectively non-opaque. They help the recipient make inferences about one resource containing another or one resource being a variant of another. In any ordinary URL, you could guess at similar interpretations, but in ARK-based URLs, the guesswork is gone. If you use the reserved characters, you are formally declaring that these relationships exist. Here are the 4 linked data rules for publishing structured data on the web, according to the inventor of the web. The way I read it is, please name things with URLs that lead to useful information and to the discovery of more such URLs. ARKs are naturally compatible with linked data because they are expressible either as compact URIs or as full HTTP URIs. Even in the case of non-resolving ARK, recipients can still learn its origin by reading the name assigning authority at the beginning. And as PIDs, they help protect our longer-term investment in semantic web and knowledge graph applications. The rule that links should lead to other links is routinely honored in ARK metadata and is always honored implicitly by ARK syntax and its suffix conventions. The slashes represent hierarchy that a client should be able to traverse. Periods represent resource variants that a client can expect to lead to receive default representations. And privileged query parameters, also known as inflections, such as !info, which we'll see later. These can predictably transform any given URI name to a set of additional protocol reasonable requests. So, for example, the simple existence of an ARK with an internal slash implies the existence of another containing object identified by its parent ARK, obtained by truncating the original ARK at the slash. There's a natural parallelism between ARK suffixes and the popular IIIF image API, which is being used in domains that have lots of images, such as medical research, museums, and botanical gardens. If you have images that use the popular IIIF framework, you can create and manage one ARK for the image and just change the suffix to identify millions of subparts and variants. Here's an example from the BNF, or French National Library. In this long IIIF compliant URL, after the opaque base name, you can read the page number F29, the comma-separated coordinates of a rectangular region, the request for full quality, and the JPEG format. So ARKs are very flexible. You can throw them away when something doesn't work out, which is much easier if you've never told anyone about them. If you don't tell anyone about your ARKs, it's as if they never happened. ARK metadata is also uniquely flexible. You can start with none, and you can add anything, such as whatever is defined in schema.org. For example, there are lots of ARKs with DataSite DOI metadata. You could assign an ARK to something that doesn't exist, because in the planning phase, things need identifiers just so we can talk about them. After all, we name our children before they're born sometimes. At the moment of birth, when we've created a thing, there might be no metadata, except perhaps for a redirection target. Later, we can gradually add draft metadata, which might be reviewed and edited by others through phases of pre-release, preprint, postprint, etc. An ARK should lead to the identified thing, to metadata about it, and to a persistence statement. ARK was the first PID to recognize that persistence is not binary, but nuanced. Here's an example. To request ARK metadata, normally you would just append a query string consisting of question mark info. This shows minimal metadata, who, what, when, where. Very unfortunately, this example is currently broken, but I'm told it should be fixed soon. So ARK metadata is very flexible, as I mentioned before, from none to anything. That includes metadata normally associated with DOIs. For example, many ARKs return metadata in the DataSite profile. This is useful for ARKs identifying journal content. Once again, unfortunately, this example is also broken, and the legacy site where it could still be shown has been taken offline for the moment. So I'm hoping that will be fixed soon. The question mark info ending is an example of an ARK inflection. An inflection is a grammatical device to modify the meaning of a word by making small changes to the end of the original word. One advantage is that you don't have to assign and manage completely separate identifiers both for the object and for its metadata. Instead, just inflect the original ARK. Earlier versions of the ARK spec called for appending simply one or two question marks, but they're a little harder to support. There's something similar called in function called content negotiation. But instead of just editing the URL in your browser location field, you need tools to manipulate protocol headers. There is no conflict using content negotiation and inflections at the same time. The response format is evolving, but it should be human and machine readable. So JSON and YAML formats are fine if you know what those mean. So persistence is not on or off. It is nuanced because, ironically, preservation often involves change. Valuable objects tend to be complex human-managed clusters of digital artifacts that curators are forced to change in order to keep up with changing technical policy, security, and legal requirements, as well as user expectations. So we mentioned the example of larger thumbnail images that creep up over time. There's also improved OCR output that's available to modern algorithms. So you can expect OCR files to be replaced. Another example is consider why does a long-term stable release of a Linux operating system from 3 years ago, why does it still receive regular security patches? There are reasons for that that are not necessarily inconsistent with preservation. Maybe to the most serious preservation person who might demand absolutely frozen bit streams, but that's actually quite hard for most places, repositories to afford. Another example, does an article cover page not change when an author's name is misspelled? Authors generally get upset about that, and repositories will comply. One category thought to be impossible to preserve is for rapidly changing files. For example, an ocean sensor file that grows every 6 seconds, or a database that is annotated hundreds of times per day. At a slower pace, it's not too dissimilar from a journal that acquires a new issue every few months. What do we even call these how do we allow for latitude in a nuanced persistence statement that allows preservation to occur on what's already been recorded, but allow these things to grow? So ARK has done some work on this, but we don't have time to get into it today. This is a look at the YAMS.net system that is supported by the Metadata Research Center at Drexel University. Note that the nan here is more than a number. It has extra characters on the end, namely /H1. This kind of extended nan is known as a shoulder. This is drawing from locksmithing terminology. ARKs are useful for vocabulary terms or concept IDs because any investment in linked data is more protected with permalinks. Concept IDs are good for things like spreadsheet column header names or variable names, controlled values under those names, relationships, pick list values, etc. Thousands of groups, small and large, across the world are inventing vocabulary or modifying existing terms, but they don't have easy ways to share and get feedback on changes. These are ARKs that point into a large substrate of candidate terms and definitions, and it helps groups to share, discuss, and reach consensus quickly on whatever terms that they will take forward into their own ontologies and standards. So we built a crowdsourced metadata dictionary called YAMS. It lets anyone look up terms to reference. You can log in to comment on other people's terms. You can also upvote or downvote terms and watch them so you get notified if they change. This term is labeled vernacular class, which means it can be changed by the owner, but terms labeled canonical class are done changing. There are also deprecated terms, but they too will always be available because historical documents will be available. You can add your own term and immediately walk away with an ARK persistent identifier to reference it. There's no problem creating multiple terms with the same name string. This one has 13 alternates, but each alternate will have a unique ARK concept identifier. You can also add tags to terms and import terms in bulk via a CSV file. Here's an example of reputation-based voting from Stack Overflow. Here are the controls to use reputation-based voting in order to resist gaming and help developers choose the technical solution that works best for them. In YAMS, it helps users choose the term that works best for them. So finally, for those of you craving a philosophy slide, here you go. Let's consider what a persistent identifier string can tell us, here represented by these 26 characters. Is it data? Is it an identifier? Is it an opaque identifier? We don't know much by looking at it, but it's useful if someone associates it with something. An identifier is really an opinion. It depends on who you ask. In other words, on which name authority you ask. If it is an identifier, it would be terribly helpful if it were inside a URL, such as this one. That's because the domain name early in every URL is actually a name authority. And the HTTPS out in front means we can query the authority implied by that domain using a web browser. When we do that, what comes back is a web page explaining that the string is an example identifier. What we won't see is that behind the scenes, the browser received a 404 not found error. So this modified string looks like a URL, but even though the browser displays a page, according to the official query status, it is not an identifier. Maybe someone else has an opinion. Let's change to a different authority, in this case, the DOI.org domain. This third string looks like a proper PID. In fact, it's a DOI, right? Well, no. When we click on it, we see a web page that tells us a 404 not found error occurred. The DOI system has no knowledge of it, and so even though it looks like a PID, it's not a valid identifier. Okay, so let's try again, but using a different sub-authority within the DOI.org domain. This time, a browser returns a web page with no 404 error. So we now have a true, valid DOI. So this should identify trustworthy, citable, scholarly content, right? Wrong. In fact, it identifies a kids movie. That's because it was created by a registration agency that assigns a DOI to every movie made in the United States. The point is that you can assume very little about an object or its persistence by looking at its so-called persistent identifier. If it looks like a PID, that is only a suggestion. What you get back also depends on when you ask. The query experiences described for this slide were made in early 2024. Persistence is not conferred by a string, prefix, or syntax. That's true whether you're dealing with ARKs, DOIs, handles, URNs, or any URL-based permalinks. Tools for implementing ARKs can be found in the resources area of the ARK Alliance website. They include minters for generating unique opaque strings, includes documentation. There's the old Noid software written in Perl and a Dockerized version of it. There's also a very nice combined minting, binding, resolving solution, which was begun by the Internet Archive and was extended considerably by the Frick collection. That's called ARKlet Frick, and that's quite promising. For pure minting solutions, you can use any simple counter or the very common UUID software, or the less common but shorter ULID software. There's also a very full-featured ARK plugin, which is a minter and resolver if you're a publisher using the Open Journal system. And the University of Toronto Scarborough has an in-house library system for ARKs that they're making available open source. If you're implementing ARKs, you may wish to consider using the suffix pass-through used by N2T and EasyID. It's also been implemented by the ARKlet Frick software. The way that works, it's a feature, suffix pass-through is a feature that a web server can choose to support in order to greatly increase the number of identifiers that it can forward. It dramatically reduces the burden of maintaining identifiers by permitting one identifier to stand in for millions. The way it works, given a URL for the stored identifier, if an ARK arrives with an appended suffix, N2T will reappend it, pass it through to the destination during resolution. This is critical for IIIF applications so that the many addressable subparts and formats don't all have to be separately registered, maintained, and possibly paid for. That is, in fact, an important limitation of the handle system and therefore of the DOI system. This idea for suffix pass-through is pretty much identical to the Perl.org concept of the partial redirect. This final case study uses a visualization from Dave Viglace and the U.S. National Science Foundation iSamples project. It allows us to visit the South Pacific island of Moorea in French Polynesia. Each of the colored points represents a physical sample, and the towers indicate that many samples were collected at the same location. Each sample point has an ARK identifier, which is displayed when mousing over it. Clicking on one of the points brings up summary metadata, which allows you to link back to the original collection. Following that link to the Smithsonian, you can find more details about the specimen with cross-references to analyses, publications, and other material. The interlinking is done with millions of ARKs, and the open source software can scale to accommodate hundreds of additional collections. Currently, the iSamples system assigns identifiers to biological specimens, rocks, and archaeological artifacts. So, in conclusion, what do 11 national libraries, 185 universities, 209 archives, 104 museums, and 101 journals all have in common? They are all registered to use ARKs. They are open, mainstream, non-paywalled, persistent identifiers that you can start creating in under 48 hours. The ARK Alliance was formed in 2018 to sustain the ARK infrastructure, and we welcome input and volunteers for our working groups. I'm also happy to remind people that we had a recent creation of a brand new ARK email forum for speakers of Spanish and Portuguese. So thank you. If there's questions, I'd be happy to take them. I haven't been tracking the chat, so if you want to go ahead and into that.
Hi, John. We have one question so far in the chat, and it said, can you talk briefly about the organization behind ARK and how it can sustain ARK over time if it hasn't already been discussed?
It hasn't been discussed. We're in very actively working on sustainability right now. We're in discussion with, we have some consultants that have been helping us to try to understand, first of all, how to sustain what it is we want to sustain, what it is, what's the value proposition, how we do it without charging fees, without going back on our word about uh, you will never be charged, you'll never have to pay for the right to assign ARKs, but some sort of revenue has to be identified. How do we do that without breaking our word to the ARK community? Um, Another question is, how do we become a preservation organization that doesn't go the way of all of the preceding organizations, which where nonprofits seem to start up and within 6 to 8 years they fold. They fold because something, what did they do that wrong that we can avoid? And that's a very tricky question. We would love some help thinking that through. We just don't want to get in the line and form a nonprofit that is then um, spends all this time worrying about its revenue and keeping its existing staff employed and paid, and then folding because under the weight of the sort of the way that can take over, you can take over your life. So I'm saying that pretty poorly, but we could use some help with that.
Okay, we had some comments and another question. One of the comments was fascinating presentation, John. Thank you. They're looking into working groups. There was a silly idea. It'd be fun to have a DuckDuckGo and or KAGI, I don't know how that's pronounced, bang command to easily resolve an ARK with into T in your browser. And then there was a question. If it
Okay,
is
well, let me,
possible,
I,
comment on those. Go ahead.
yeah, it would be great to have, essentially, it's been the dream of every persistent identifier scheme to be recognized by the browsers and unfortunately, the browser makers never really took that seriously. Probably the closest they came was with the URN, recognizing it as a URI scheme, but the, there's no there's no resolver for the URN. There's no known resolver. So I agree. It would be great if you could do it within the resolver and with minimal fuss, like less fuss than installing a plugin. Of course, that the whole plugin landscape may have changed since I last looked at it. So I'd be happy to explore that and talk about it more if there's easy way to do that. Sorry, Ronnie, go ahead with the next
No,
one.
never apologize to me on that one. Someone asked if you will be uploading your slides into
Yeah,
schedule. And
yeah.
then is it possible to have an ARK without any metadata? How can what the ARK identifies be known?
Well, you could say that there's the question of there's the arc between you and yourself. You may know exactly what it stands for, but generally, especially if they're opaque, you'll need some sort of note for yourself. So there's a question of like, who do you tell about it? Um, so the very usually the if the very first bit of metadata that an ARC has is the URL that it redirects to. So you may not know anything about it except, well, it redirects here, so that's probably what this ARC is about, is that thing. So you could say that an ARC without a redirection target is almost useless. I'll tend to agree with that, except if it has some personal meaning to the creator. ARC with the redirection target, that gets you kind of the typical experience of any URL shortener or Perl.org. A lot of Perl.org links, wordlessly get you to a place. So that's something, and often that satisfies a number of people. But properly speaking, I mentioned that identifiers and metadata really go hand in hand. When a thing's not available or it's temporarily not available, to have some knowledge of what it's been bound to in the past, basically, effectively, metadata is super important for identifiers as is one of the pillars of identification. I'll stop there.
And we have one more comment. They said it was great to learn about this. Thank you. I'm going back
Okay.
to see, make sure I didn't miss any and check. If you have any more, we still have time. You can go ahead and put them in, or any other comments.
I really appreciate the chance to talk to your folks and the questions that are coming up. Um, the infrastructure, as I'll mention, is a little bit is still in flux. The California Digital Library has been doing a technology refresh, and there's always a little dust that settles, still has to settle with the latest refresh. And we're modernizing the way that NANs are assigned, and the, uh, the code, the software base got a lot simpler. So, and it's written in Python instead of Perl, so that attracts many more developers. But we're quite interested in new working group volunteers. We're an all-volunteer organization at the moment. We're working hard to become a legal entity, so we can have a bank account and own a domain name. Wouldn't that be nice? Um, Help on all fronts would be very welcome.
What advice do you offer to individuals that are kind of new to this kind of work? Like how to get started, what resources to kind of look at?
Well, that resources page is a good starting point. Another one is you can request a NAN for your organization while you're still making plans. A lot of people ask it for a name assigning authority number when they're just getting started, so they don't yet have a resolver. So it's something you can sort of figure out. Extremely um, there are some extremely easy ways to get online. If you have, for example, if you are really depends on the application. So OJS, the Open Journal System. If you're already using that software, there's a nice plugin that you can just configure it and you get a NAN. You configure your plugin and you're off to the races. You're already using them. If you're using, there's a couple of sites that are basically WordPress sites. Um, and you can do some things very informally and manually. Basically, your local resolver is just your local web server, and the main trick is to here comes here comes an incoming URL to your local web server, but it looks like an ARK, so it has to be on the way in. It has to be transformed into one of your URL paths, and so typically, unfortunately, that needs either a little bit of technical staff or it needs a platform that's already has a solution available for you. So, often it's one technical person can get you there. Sometimes I'll mention Project Gutenberg. That's they have some of the most persistent identifiers in the entire digital library field, or that they've been doing they've using the same identifiers from before the internet was created. And they had an Apache web server and basically two lines of rewrite rules, two-line configuration change allowed them to take ARK identifiers coming in and map them to their existing identifiers. So that was for them a trivial change, but they also have technical expertise, a homegrown system that's was easy to modify. So unfortunately, the answer will change a bit depending on your situation. And what we could use actually is we could use better documentation that sort of says, if you're using this platform, here's a recipe, and if you're using that platform, here's a recipe. We need to collect some recipes for bringing people online easily.
Oh, that would be nice. That was awesome. Does anybody else have any questions? Last call. I feel like a bartender right now. Last call. Well, this was great. I appreciate you sharing this. I love, like, I'm not into anything linked data. I'm not sure how I ended up helping with this conference. It's my third year helping with it. But I love coming and learning about it. So I love that you shared this. It's great. And
Well,
I
thank you
really
for the chance. Appreciate it.